Good morning, everybody, and welcome to this Windows Azure webinar. My name is Andrew Smith. I'm going to be your host today, and I've got Luke Smith.
Hello, I'm Luke Smith. I'm the Azure IS Practice Lead at ICS Solutions.
And I've got Mark Harrison.
Hi there, I'm Mark Harrison. I'm a Microsoft Technical Product Specialist.
We've got an hour this morning to cover off Windows Azure, and we're going to spend about 45 minutes taking you through some slides. If you could put your questions into the chat online, and what we'll do is we will try and answer the questions as we go along, but our plan is to finish in about 45 minutes and for you to then have a 15-minute Q&A. Okay, so just a little introduction to ICS Solutions. We're a Microsoft Gold partner, and we are working closely with Microsoft to help clients in all sectors that take advantage of the Microsoft Cloud technologies. We cover Office 365, which is the email, SharePoint, and Lync cloud offerings, as well as Windows Azure. And today's session is going to really focus on Windows Azure and how customers in the public sector can take advantage of this infrastructure as a service technology. We engage in a flexible style with our clients, so we can run a project for you like we have done for clients like Harrow Council and Bucks County Council, or we can provide resources to you to augment your team with specific experience in the technologies that we are going to cover today. I'll talk a little bit about the next steps at the end of this webinar. As I mentioned, we work with a number of different customers with different views to how they can implement the technology, and we have a specific methodology that I'll come on to that we talk about how we use it. But just to highlight some of the work that we have done, we're currently working with a London council to implement a SharePoint Online solution, and also a number of other county councils who are looking to take advantage of the Windows Azure offering as it provides them with some flexibility. And we'll touch on a little bit about some of the business value and some of the drivers behind Azure in terms of why customers are looking to implement these solutions. But we have a broad range of those technologies and understanding how to deploy it. With regards specifically to the Microsoft Azure offering, we have a four-step process that we encourage our clients to undertake with us if we engage with them to help them on this particular journey. You can see on the slide the four key elements. They're pretty self-explanatory. The assess bit is really just to determine if there is a fit for Azure and for some of the capabilities that Luke will be taking you through within your organization and how best it could be used. The pilot is obviously an opportunity to identify a smaller scale implementation that we can really test Azure and make sure it meets your business and technical requirements. We then typically move on to a more comprehensive deployment, and then once we've got a successful working solution that the business have seen the value in, then we look to expand and enhance that by looking at other workloads within the organization that might be a good fit for Windows Azure. So that was a very quick introduction to ICS, the professional services that we provide to help our clients, and how we would like to engage around the Windows Azure platform. I'm now going to pass over to Luke, who's going to spend the majority of the remaining 40-odd minutes to talk through a particular scenario that we have of one of our clients and how that might be relevant to Azure, as well as the Azure stack as well.
Thank you, Andrew. Okay, so we're going to start and have a look at Windows Azure. Before we get into Windows Azure, there's a couple of challenges that we faced with the regional and central government organisations that Andrew has mentioned, and they're probably common across most public sectors. So there are, within public sector, issues around budget, increasing demand of resources, pressure to do more with less, and also this tension between innovation. So if you're trying to innovate a new application, sometimes that may be stopped by policies or security requirements. Obviously, there's also the end-of-life that's coming along with Windows Server 2003, which is due to go end of life in 2015. So there's probably now, as an organisation, you want to try and look at how you can migrate your applications from the end-of-life products and work out how that would work moving forward. And we can use Windows Azure to sort of model how those applications would work running on a newer operating system and how you would extend the software. And then you could leave that application running in production in Azure or continue having a development and test environment. So there are some key reasons that you may want to be using the Microsoft Cloud. Look at reducing the costs, more control, look at moving from CapEx to OpEx, and look at reducing risks. So if you're having to design an application and you don't know today what the requirements would be for the compute, you can use Azure to allow you to start small and then burst the compute as required, and hopefully eliminate some of the IT headaches that you currently have, maybe time to procure environments and deploy those. So we've got some strong scenarios that we'll be talking about for how and why you'd want to use Windows Azure or the cloud in general. So we're looking at the ability to burst the compute, and also doing sort of government to public-facing applications. So there's a lot of public applications and delivering of services to the public that could be done using Windows Azure, as it can publish internet-facing applications. And there may also be government to business. So this might be government organisations who have to work with third parties and interface with those, and how Azure can assist with that. And you might need to be looking at extending your data center or replacing your data center, and maybe Azure can be used here to help with that. What we have here is a scenario of a local and regional government that we've been working with, and to the left of the screen are sort of how the applications and server environments are built up, along with classifications of that data. So within public sector and regional governments, there's a classification of applications which are IL levels. And they're classified from IL1 up to IL6, although typically the higher end of ILs exist within much securer organisations. So here, as I say, we're looking at a local regional government and having to deal with the different types of applications. And these applications may need to communicate to third parties. So there might be third parties that are having to deal with streetlights or facility management and how you would interact with those. Maybe there's some sort of messaging communication system that you already have in-house, or you might be looking at implementing, and that could be done maybe within Windows Azure. You also have to deal with the citizen user base who come in and want to fill out forms or pay for their housing. And that's delivered over the public internet. So that could be another key area that could be moved into the cloud. And we also have remote council workers, so users who work at the council that need to be able to gain access to the data, and that could also be done in that fashion. The reason that I wanted to highlight the different IL classifications is because Windows Azure has been given the certification for IL2. So it's now plausible to move the applications that we've got classified there into Windows Azure. And IL3 applications tend to be systems that you would consume from, so that the working pensions or adult and children personal information that can still stay segregated, and that would be done via means of a firewall that you would probably have within your organisation. And not to forget that there's not just one office within the councils, there's probably lots of council offices that you have to be concerned about and allow communications to those applications. So we can talk about how that would work within Windows Azure. So really what we're talking about is there are a variety of different server applications and products. We're having to deal with maybe a large amount of data and a large amount of servers. And we're going to be focusing really on that IL2 side of the infrastructure and talk about ways within Windows Azure and Microsoft Cloud Services on how we can help tackle the data explosion and server explosion. So we're going to look at how Microsoft define their cloud. So within Microsoft, we have two types of clouds, a private cloud and a public cloud. A private cloud would be an environment that would be hosted maybe on-premise within your organization or hosted within another data center, colo type data center, using Microsoft technology such as Windows Server 2012, R2, and System Center with the Azure pack. The public cloud is what we're going to be focusing on today, which is Windows Azure, particularly the infrastructure as a service platform. And what's key to the Microsoft positioning is this hybrid model, being able to host applications between your private and public cloud and being able to move those applications freely between those two environments. And here we have the list of the cloud services and solutions that Microsoft offer. So to the left-hand side, we have the public cloud, which we'll be focusing on, but particularly Windows Azure. But it's also worth noting we have Office 365, Yammer, so hosted Exchange, hosted SharePoint, which are also IL2 compliant, CRM Dynamics, Windows Intune for managing devices and bring your own device policies, Windows Azure, which we'll go into more detail, and then on the private cloud side of this, we've got Windows Server 2012 and System Center. And System Center can act as that glue between a private cloud and the public cloud. And we'll be focusing on Windows Azure. Okay, so just to recap then on the different hosting models. To the left-hand side, we have your traditional on-premise environment, which may be physical or virtualized. Within that infrastructure, you have to be thinking about all of those elements highlighted. So you need to understand your networking, your switches, your storage arrays, and deal with the capacity on your storage. The physical servers that are used to run the virtualized environment or physical environment, then the virtualization level, up to the OS and data. Then we move into infrastructure as a service, whereby the elements highlighted in green are those that are managed by the vendor. So you no longer need to be concerned about if that storage array is available, if there's enough storage available for you to provision your guest operating systems into, or the networking that's used behind that. You're now just concerned with that operating system you've deployed and any middleware or applications that run on top of that operating system. And I'll go into more detail on what operating systems are supported within Windows Azure. Then we move into Platform as a Service, which also sits under Windows Azure. And what we're doing here is taking away the management of the guest operating system and the application middleware that is running, leaving you to just deal with the bespoke application you've created and the storage of that data. An example of that might be a website that is storing data, or a web service that's consuming data or pushing out public data. And Platform as a Service is really a development practice using Visual Studio.net. And if you are interested in Platform as a Service, then please let us know, and we can probably go into more detail on that in a separate session. And then finally, it's moving into Software as a Service, which is more of a business model. Typically here, you don't want to be worrying about the application or the solution that is running. You just have a need. That need might be email. And all you want to do is be able to consume an email service without having to worry about the management of that service and the availability of that service. And that's where Office 365 would come in. And we have other seminar programs that discusses Office 365 in more detail. If you're interested in that, then please do let us know. Okay, so we're going to now look at Windows Azure, and particularly infrastructure as a service. The slide that I've just opened up on the screen sort of highlights some of the key features of Windows Azure. So the Microsoft investment in the data center, 2.3 billion, which keeps growing. In fact, on that investment, Microsoft have announced the expansion, once again, of their Dublin data center, so they're redoubling the capacity. So it's really showing the demand of the adoption of Windows Azure. We also have a financially backed SLA at 99.9%. And I can talk about how we can increase that SLA as well from Microsoft. We have 8 data centers across the world, and we have content delivery networks. The important thing, though, for the public sector would be the compliance and DR. And within the compliance and DR, we've now got IL2 accreditation, and in fact we are on the G Cloud, so we can easily adopt within government Azure by using the G Cloud catalog. And last week we also gained PCI DSS compliance. So if there was any credit card or credit card sensitive information, that accreditation has now been provided. So I've got some large figures up there. What does that mean? Well, the 200,000 is the amount of registered customers that Azure had as of December last year. And the 1,000 is the amount of customers that are signing up to Azure on a daily basis. So there's a heavy adoption of users, which have accelerated when Microsoft released infrastructure as a service. So just to recap on where those data centers are located, we have 4 within the American region, 2 within the European region, and another 2 within APAC region. These are, we have the data centers which are shown within the diagram here. In the top right is the Dublin data center. But what's also important to highlight would be the image in the left-hand side, those containers or modules. That actually stores a large amount of computers and storage, and that's effectively the fabric, we call it, so the underlying host operating systems that operate. And in fact, when we have a server failure within one of those modules, the server isn't replaced. If it can be self-fixed within that core, then it will be. But the module allows for an amount of failure, and once that threshold has been hit, we actually replace that module completely with another one. So we provide for enough capacity and ease of connecting up. And the newer generation modules also include the cooling. We also support our data centers with a global content delivery network. And what that allows for is asset content on websites to be stored locally to users. So an example of that might be you're running a public website, and that website has assets, images and videos that are commonly used and aren't changed. Those can be pushed out to the content delivery network that Microsoft has to make sure that content is delivered much quicker and faster. We also have global support, so we follow the sun, and the support is 24/7. We currently have 20 billion businesses utilising the platform. This is also supported by the Microsoft local account teams. So in each region, there are account teams aligned to businesses that are here to provide you with account support. And we also build in local currency. Some other vendors will probably want the currency done in dollars, whereas here at Microsoft, we try to do this in local currency, in pounds and euros. Okay, so what do we have within Windows Azure? We have really two key elements that we sort of consider within Azure. First is the compute, and then secondly are the application building blocks. Within Windows Azure, we have compute models based upon virtual machines. So this would be a virtual machine that you would traditionally have within VMware or Hyper-V. We have websites which are very similar to what you might find from GoDaddy or 123reg. These are IIS websites that can run PHP, HTML, ASP.NET applications. We have our cloud services. So this is now looking at platform as a service, whereby this is a development practice, which would be done within Visual Studio.NET. We have media streaming services. So the Olympics and Winter Olympics are being broadcast using the media services to mobile devices. And the idea behind this is it can scale and understand what mobile device is being, the content's being rendered to, and then provide a quality of service and acceleration around that. But what's key to those compute elements are the application building blocks. So we couldn't have a virtual machine without storage. So storage is key for how we store the data, and how we would then network that, how we would extend our organization to access those services seamlessly without users knowing that they were located in a different location, and identity, how we would connect to those and backup. And we have other elements in there around integration, service bus, mobile, caching, HD Insights, which is the Hadoop service hosted by Microsoft. And these would sit around platform as a service, which we can go into more detail in a subsequent session if that's important to you. Okay, so now we need to sort of think about within our organisation the type of systems that we run. And these are probably across all of organisations, whereby you might have environments that need to be switched on and off. These could be development and test environments that aren't used all of the time, but they still need to have some reserved capacity within your organisation. And we can touch on how that would be beneficial within Windows Azure, how we can sort of bring that cost down on your internal infrastructure. And also, you know, the unpredictable bursting or an application growing fast. How do you cater for that today? Maybe you have to size your application far beyond its current needs. Maybe that can be done better within Windows Azure with what we call auto-scaling. But you also may have applications that are just steady. They just run 24/7, consuming a similar amount of compute throughout the day. And those can be also moved into Windows Azure. And what we're looking at here in the middle is really those systems that have that maybe unpredictable or predictable compute power. And what we're showing really where that saving of 60 to 80% is that we've got an application here which is seasonal, whereby there's a lot of people that are accessing it within a particular month. And we can see a great saving within Windows Azure with the ability of auto-scaling our applications. So now we're going to have a look at storage in more detail. So we currently have 4 trillion objects within Windows Azure, a mass amount of data. And there was an independent report done by Nasuni at the end of 2013 that actually looked at the top cloud vendors, Amazon, Rackspace, and rated the speed of read and write to data, and Azure actually led that. They surpassed that of Amazon. And if you're interested in that report, then let us know and we can provide that to you. So how does the storage work? So within Windows Azure, there are effectively 3 copies of that in different arrays across those different modules and pods. So in the event of a failure, there's another 2 copies there available. And what would happen is the 3rd copy would get regenerated in the background. So with storage, we are very confident that we shouldn't see an outage from a failure because of the redundancy built in. But we can go one step further and we can have geo-replicated storage. This is whereby we take the copies of the data and then move that to the secondary data center. So within Europe, the primary data center for the UK would probably be Dublin, being the closest to us. And then the secondary one within Europe is Amsterdam. So when we enable this geo-replicated storage, there would be another 3 copies, in fact, within the Amsterdam data center. So in total, 6 copies. So we shouldn't have a case where there would be without data. And now we're looking at virtual machines. So Microsoft provide support for their Windows Server products out of a gallery that can be deployed very quickly. And we also provide support for Linux varieties of operating systems, so OpenSUSE, Ubuntu, CentOS. And we've also registered up with Oracle, so Oracle are now on the supported list. And this list keeps getting bigger, and that's the idea with Azure. It's an evergreen service that will always be moving, and there will always be more updates. And the other thing that I wanted to highlight here were these are the operating systems that Microsoft have by standard. You can bring your own. So there's an important vendor that's not listed on here, which is Red Hat. If you had a Red Hat environment and you wanted to bring that to Azure, you can. The support would be done with Red Hat in that instance. That's where we have My Images and My Disks. And the other important part around My Images is that if you have a standard build practice that you follow within your organization, maybe you have a development environment that has all of its prerequisites built within a template, you can bring that to Windows Azure to make the provisioning of those VMs much quicker. So we can interact with the provisioning of those VMs using the management portal. We can also do that using PowerShell scripting. And there's also a REST API that can be used to interact with the virtual machine provisioning. And that REST API, you can either build an application internally that could interact with that, or you can do it using System Center. And that brings us on to the next slide, really, around the automation. So we can automate the provisioning of virtual machines using PowerShell. We can also automate it with System Center. There's a product within System Center called Orchestrator. And we can kick off these runbook jobs to provision services within Windows Azure. And that would be augmented with App Controller within System Center and maybe Service Manager to provide a self-service catalog. We'd need to access those machines for virtual networking, which we'll go on to later. And storage, so I've touched on we can upload VHDs from on-premise to Windows Azure using PowerShell or System Center or other third-party products that are out there. And the virtual machines, which are key to identity, once we've got that virtual network in place, we can provision and extend our Active Directory and then join our servers within Windows Azure to our Active Directory. This could be your existing AD you have internally, could be a child domain, could be a separate domain with a trust. There are all these options available. Microsoft have a selection of virtual machines, 8 in total. This is what we would call the compute. I get a lot of questions asked of me saying, well, I like that we've got 4 processors or 8 processors, but can I have 7 gigs of RAM? Unfortunately, you can't pick and choose the virtual machines. They are the standards which are listed in that order. starting with the extra small A0, going up all the way up to A7. The costs that are provided on the sheet here are those which are pay-as-you-go, and would be much lower when delivered via an enterprise agreement. So an enterprise agreement can be procured directly for Windows Azure. That can be done through with your LAR or can be done through the G Cloud. And that would allow you to obtain a much lower discount. And depending upon your organisation, that discount can be much higher. It's also worth noting that Microsoft were the first cloud provider to do pay-as-you-minute. Before, if you only wanted to use the compute for 30 minutes, say, you were rounded up to the nearest hour. Whereas now, rather than rounding up as it was traditionally done, we now round those back down. So if you only use the compute for 45 minutes, you pay for 45 minutes of that. This would really make development and test environments much cheaper to run, and maybe where you've got a large application that requires a large amount of compute for a short period of time, maybe doing some data modeling, and you need to have a large amount of servers or cores to be able to do that. But with this, it makes it much more affordable to be able to do that compute processing. We also now, when we turn off a virtual machine within the portal, before when it was turned off, you would still incur a charge, whereas now when we stop the virtual machine, they get deallocated and they no longer incur a charge, but allows you to start those virtual machines up much quicker back to where they were before, rather than having to regenerate a virtual machine configuration file. And the other costs that sit around a virtual machine is not just the compute. We also have storage that we need to be concerned with. The amount of storage transactions that would be running, as well as the bandwidth that the application is consuming. It's worth noting that the bandwidth is free for communications within the data center, so applications communicating to each other would be free, and communications up into the data center, so from on-premise, uploading content to a virtual machine is also free. So the only costs that we have to deal with are those that are coming outbound from the data center. And with the new backup service, we can now provide backups into Azure. So where we have those virtual machines running within the cloud, we can run backups into the Windows Azure backup service. Now, Microsoft are looking at reducing the costs around storage and transactions in March. So it's definitely worth keeping an eye on what those would reduce to. Within Azure, we have availability sets, and the reason that I wanted to discuss availability sets is this is where an improved SLA can be gained. So rather than the 99.9% that's by default, we can go for a 99.95 financially backed SLA. And what we're doing here is we're basically doubling up on our servers. And Microsoft see that if an organisation has put in this investment in, then they should get some sort of remuneration back if there is a failure to this environment. So within our model here, we're showing 2 virtual machines running IIS and another 2 virtual machines running SQL Server with always-on availability group replicating those databases. And we put those into fault domains. So what does that mean? We basically are moving those hosts, those guests, from the same host potentially into a different host, so that when maintenance occurs, we're only taking out one virtual machine set and then running it off of the second side. And then once we've maintained the underlying fabric, the virtual machines will come back up, and then we can patch or resolve the issues on the secondary server. So we're trying to make sure there's always availability to your solution. How do we access those virtual machines? We can do that one of two ways, and the preferred way would be via a IPsec site-to-site VPN. What this is effectively doing is extending your internal networks into the Azure cloud. And the key part around this is that you can still segregate your traffic on-premise between your IL2 and IL3 traffic, so that when communications are to Azure or back from Azure, you can sort of broker that and make sure that the right information is going in the right direction. Systems, they can just access that as they traditionally would on-premise into Windows Azure, so extending that network. And this is what allows us to extend the Active Directory domain. We can also add to this point-to-site VPN, so our remote workers can now terminate at the Windows Azure VPN device, and we use a SSL VPN client to perform that connectivity, and that would be another route that remote workers would be able to access services within Windows Azure, and can also access services on-premise. We can also define access control lists within Windows Azure from the public access. So there might be third parties that you work with that you only want them to be able to access particular services within Windows Azure. And you can do that with access control lists. You might want to completely block traffic to particular virtual machines, and that can be done by restricting what we call endpoints. And endpoints are the firewall and load balancer products that we have within Windows Azure. And we can completely deny ports, and we can deny IP ranges. It's also worth noting our compliance and accreditations within Windows Azure. And you can view these on the Windows Azure website by going to www.windowsazure.com/trustcenter. And there we provide a lot of detailed information around the compliance and security credentials that we have within the platform. So we have, as I mentioned, the UK government accredited IL2 certificate. We now have PCI DSS Level 1 accreditation, as well as the EU Safe Harbour and data protection. So keeping that data safe and within the relevant boundaries that we require within the UK and Europe. We also offer different support packages from Microsoft for Windows Azure. And as a service provider, we can also add our support in addition to this. It's key to note, though, that when you procure a service within Windows Azure, you get free community support as well as access to billing and subscription support. And for most organizations, you would probably look at stepping that up to provide a more improved SLA for the services that you are running. So you might want to consider standard or Pro Direct. And what that allows for is the technical support of the Azure infrastructure service and the products that are deployed that Microsoft List has supported on that platform. So, for example, any issues with the Oracle or Ubuntu Linux varieties would be routed through this Microsoft support service. If you have issues with the SharePoint platform or Windows operating system, those can be done through these services. And as ICS, you can supplement this to, in addition, support the applications that are being built and that we may have assisted with or that we take on for you as an organisation. Okay, I wanted to now touch on a couple of scenarios and some other products that Microsoft have been involved with. And one of those is Store Simple. The reason that we want to highlight Store Simple here is that we find that organizations can use this appliance to move much quicker to realizing the cloud vision. So what is Store Simple? Store Simple is an array, very much similar to a NAS or SAN infrastructure. And it's a device that sits within your organization within a rack. And you would connect to this device using iSCSI connectivity from a Windows server. And what we're trying to do here is target that large amount of unstructured data you have within your organizations. So things that may sit within file shares or users' home directories, that you have to deal with backups and the ever-growing capacity. So the Store Simple then can come in here and provide this ability to burst the storage into Windows Azure. So we can put this device in and then consume the petabytes worth of data that Microsoft have available to store this information. So what we're doing is the Store Simple appliance is acting effectively as a caching device, synchronizing data up into Windows Azure, keeping the hot data that people use regularly on the local device, and then data that can be archived would be automatically pulled into Windows Azure. The product itself handles the tiering. So we have two types of storage. We have fast disks for very quick disk access, which we run at the front of the Store Simple device. And then at the back of the Store Simple device, we run SAT disks. And these can then be used to offshoot from a compression point of view. We can then deduplicate that data. And once it's compressed and deduplicated, we then move that data within Windows Azure, of which we then encrypt. And the important part around that encryption is that you keep hold of the encryption key. So the data that's stored up there could not be accessed unless that key was provided to an organization to be able to access it. That would be within your hands. And the synchronization of the data is done at the block level. So the storage array doesn't actually understand what files are on there. It's all done by looking at the block and fingerprint level. So we can really see a cost saving within our organizations that look at adopting Store Simple, typically a 40 to 80% total cost of ownership. Because what the device can help us remove are the additional steps that you have to think about on premise. So maybe replicating that disk array if they're for resilience purposes, taking snapshots, then backing that up using a media server to another disk array, to then outputting that to tape. Then you probably have to pay for the tape to be stored off-site, maybe with another third party. And what we're doing here with the Store Simple appliance is that helps to get rid of some of those, some of that extra complication and costs, so that when we now do backups, we can do those straight up within the cloud. The data is automatically already in the cloud, so that we've now got this off-site backup already catered for within our storage array. The built-in resilience that I touched on within the cloud storage. In addition to that, we've got that geo-replicated. So not only would that data live within maybe Dublin, it would also be replicated to Amsterdam. So there is a lot of good reasons at looking at moving forward to the Store Simple. And at Microsoft, we're currently running an offer on this device, which we will touch on at the end of the session, which should hopefully make it even more compelling to look at utilizing within your organization, taking that first jump to the cloud. And you could then look at supplementing this with virtual machines within Windows Azure. So now within the organisation, so the example that I was talking about before, we can now look at moving those IL2 services within the Windows Azure platform. So things around storage and the compute will hopefully become much more improved. The IL3 data could still live on premise, or could be looked at hosted within a partnered hosting center to provide you with the private cloud, which we can go into more information if that's of interest to you in another session. So if we sort of remove the IL3 for the moment, what we're doing here is now providing the access to those services from Windows Azure. So the websites and services that citizens currently utilize, they can consume that from Windows Azure. The integration and collaboration that you may have with your third-party organizations can also be done through Windows Azure. Those can be done via accessing IaaS services directly, or maybe using the integration services within Windows Azure. So it's important to note that Microsoft have an integration product called BizTalk, and BizTalk can be hosted within virtual machines within the Azure platform as a service. And there's now also BizTalk services within Platform as a Service. So we're really trying to help organizations integrate with third parties and other systems. And that would just leave you on premise with networking devices, printers, and storage. So really just to recap, we can look at using an enterprise agreement for the initial sign-up. We can use MSDN to sort of trial and have a look at infrastructure as a service. We also have the IL2 accreditation and PCI DSS, and I'd highly recommend looking at the Trust Center for the accreditations. The data centers are also independently audited by Deloitte, and your Microsoft account manager should be able to provide that information to you if that is of importance. So just to recap of all of the services within Windows Azure, we've mainly looked at the central part of this table, the compute, the data, and networking. And we've looked at these very quickly. If you'd like to know more on these, we have a seminar program, or the assessors, that will go into more information to help you understand how this would look within your organization. And then at the top of the app services, the Platform as a Service, which we can talk to you about in more detail if these are of interest to you.
I think with that, I'd like to bring this webinar to a close. I'd like to thank you all for your attendance, and hopefully we'll speak to you soon.